Okay, so of course, this week we're talking about EIGRP, and so the topology I've got here at the moment is 3 routers connected in a loop, and then there's this router 2 has a connection to the ISP. It's not a very full-featured ISP, but it'll do for today. And so I have configured the devices, and so if I hover the mouse over, you can see that there's IPv4 and IPv6 addresses on all of them. I haven't configured the switches. My care factor is low. And so they're all configured, ready to roll. But, of course, I haven't done any routing protocols. And so if we have a look at show IP route. Well, this is router 2, so it's got a default route. I've configured that, but that's pretty much the only routing I've configured on this router is this default route. It's got a gateway of last resort or static default route. And so, yeah, that's about that. Now, if we look at show IPv6 route, again, not greatly different. It's got a default route here, but basically there's just the directly connected networks and that's it configured. So that's the only thing the routing tables have got at the moment. So how do we get EIGRP working? So we'll have a look at this document. And so actually this top bit here is just how I set up the IPv6 addressing. As you can see, I've actually commented them all out just so I could reuse the same ones and just edit it a little bit. And that's how I did so that's the R1, 2, and 3. This is the ISP and default routes as well. So, all right, this is where we start looking at EIGRP here. And so, of course, you type in router EIGRP1, and so, of course, that 1 means the autonomous system number, and so that needs to match on all your routers. And so that's all you need to do there. And of course, then there is some settings you need to create. Now, you don't need to create a router ID, but it's normally a good idea. And so because it's router 1, I've given it the ID of all the ones. And then the network commands. And so if we look at router 1 here, we've got 172.16.1 and 172.16.3. And so that's actually covered by this. Both of those networks are covered by this one network statement because it's B class. It will cover all of the 172.16s. And it's also got this network statement for 192.168.10.0. And so that, of course, covers this WAN link here. So that's all we need to do. Now, of course, there's no other routers on the Ethernet network. This is just a host access LAN. That's all it is. And so there's no point sending updates across that link. And so we just do passive interface on it. Now, because EIGRP bases its metric on bandwidth, among other things, we need to set the bandwidth of the serial links. And so if you remember, serial links assume 1544 kilobytes or 1.544 megabits per second. And so we're just going to make this link here a 64K link. And so that's what this bandwidth 64 is. We're going to make this serial link here 1544. And so that actually will that config will actually disappear because it's a default setting. And so that's basically all we need to do there. On router 2, basically the same. You've just got to make sure you've got all the networks included that you need to. And so router EIGRP1 again, of course. Router ID of all the 2s. And so the network commands, we've got 172.16.2 and we've got 172.16.3 that are directly connected to this router. So again, this B class statement covers both of them. And we've also got this WAN link, which is a part of 192.168.10, and so we just have that network command there. Again, the Ethernet interface doesn't lead to any other routers, so no point sending in updates over there, so we're going to passive interface it. So this bandwidth 64 is the other end of this cable, of course, and so both have got corresponding bandwidth settings. Now this link here we haven't looked at before, and so we're setting the bandwidth to 1024. So a bit slower than that, but a lot quicker than that. And so that's about it. And so one thing you will notice is this network here linked to the ISP does not have a wet network command at all, because the ISP is a different company. And EIGRP is an interior gateway routing protocol. And so the default route that is on this this router will get packets out to the rest of the world. So we don't have to run a routing protocol across it. And so with router 3, basically, again, router EIGRP1. Of course, its router ID is all the 3s. And so when we look at the networks connected to it, there's 192.168.10, and these two WAN links are 192.168.10. Different subnets of 10, but there's subnets nonetheless. So these two network commands will cover it. Again, we're going to passive interface the gigabit because there's no other routers there. And so this corresponds to this link here. So we're setting it to 1544. And of course, this interface here covers this link, which we set to 1024. So I've commented out the 1544. So I'll apply these to the routers. So paste it in. And so have a look. There don't seem to be any errors. And so we can always do a show run, see that everything we did stuck. So nothing happened on the gigabit interface at all. We've set the bandwidth to 64 on this serial. We set the bandwidth to 1544, but as I said, that's the default setting, so it doesn't actually show up. And it's got router EIGRP1. It's got passive interface. It's got the ID, and it's got the two network commands. So that looks pretty good. We can also do show IP protocols. And basically the information here, we've got autonomous system number of 1. I haven't played with the constants, and so it's only K1 and K3 that have been set to 1. That's the router ID. That's the default administrative distance. These are the network commands that, of course, I put in. We've got one passive interface. And routing information sources, well, it's the only router that's running EIGRP at the moment, so it hasn't spoken to any other routers. So we'll come back to that and have a look later once we've configured some more routers. So now we can do router 2. Copy. Paste. Again, I don't see any errors popping up. But we've had a new adjacency. Now there's two routers that we've got with EIGRP. They're starting to talk. So if we do show IP prot now, and so one thing that's different compared to the previous router is we've actually got this routing information source. So of course we've got our network commands there, got the passive interface, and pretty much all those other settings, apart from the router ID, will be identical to the other router. So we can, of course, do show IP route, and we should have hopefully learnt some routes. And we have. Now, of course, this is router 2. it's got those static routes in there, so it's got that default gateway, but it's learnt this route from router 1 to router 1's LAN. It's also learnt this route to that WAN link between router 2 and router 1 and router 3, sorry. And so, of course, it's got the static route. But if we go back to router 1, you can see the message for adjacency change. If we look at show IP protocol, of course, now we've got another routing information source. So if we do show IP route, of course, we haven't gotten anything going with the default routes yet. We haven't shared that, but it has learnt this WAN link from router 2, and it's also learnt the LAN from router 2 as well. So it's exchanging information, so that's a good sign. So let's get router 3 going. Paste into it. Again, we don't have any errors, but we do have 2 adjacencies because this is the 3rd router, so there's 2 other routers. So that's good. So we do show IP protocol. As you can see, there's 2 routing information sources now. Again, we've got the passive interface, 2 network commands, and everything else is identical except for the router ID. So again, if we do show IP route, so I might widen that to make it a little bit easier to read. Well, one thing I might do first is we've got 1, 2, 3 LANs and we've got 1, 2, 3 WAN links, not counting the ISP. So if we look for that kind of information, so we've got these 3 networks here, the 3 Ds, that's cool. And if we look for the 3 Cs, 3 more connected networks as well, well, that's a total of 6 networks. So basically, these routers know everything that they could possibly learn without me doing a little bit more work with the default routes. So that's working quite happily. Suppose we can do. Did I do show IP protocols earlier? Yes, I did. But one thing I haven't done is show IP EIGRP neighbors. And so, of course, this has got two neighbors, one over serial 001 and the other one over serial 000. And so, all seems pretty happy. So, happy at the moment. So, how do we do it with IPv6? Now, I've actually thrown a little bit extra in because in my setup, I never actually set a user-friendly link local address. So I've actually thrown that in as well. But basically, of course, to get IPv6 routing to work, you've got to turn it on to start with. And so IPv6 unicast routing, got to do that in global config mode. And then we turn on EIGRP by this command here, IPv6 router EIGRP. I'm using autonomous system 11. And so this is router 1, so I'm using 2 ones times by 4 for the router ID. Again, we're passive interfacing G00. Now, of course, when it comes to router IPv6, you don't do network commands to get the networks participating. You actually do it on a per interface basis. And so on router 1, we want G00, and we want S000, and we want S001 to have this command in there to have it exchanging EIGRP routes. So you'll notice with the link local address, I'll put the same address in on all the interfaces on this router. And so that will work as long as I don't put that same address on any other router, it will work nicely. So we'll just throw this in. Copy. Might widen it now. Paste. All right. I don't see any errors. So that's a good thing. So if we do a show run, there's the IPv6 unicast routing command in there now. And then, of course, I've thrown in that extra link local config as well. And then this command here says, have this participate in EIGRP. And then with the two serial links, again, we've got the link local address as well as the EIGRP command. And so for, oh, sorry, that's the V4. For V6, basically all we've got is the router ID, no shutdown, and passive interface. Now, of course, we do show IPv6 protocols. And so basically from here, we've just got the EIGRP 11. So that's its AS number, of course, is 11. Haven't played with the constants. And so the interfaces that it's been activated on are the two serials and the gigabit, and of course the gigabit is passive. And so that's, you don't get as much information with IPv6, show IPv6 protocols. We do show IPv6 route. We won't have learned anything yet because there's only one router on it, but so that's basically what it looks like. Now, we'll throw in router 2 as well. So router 2 really only differs in that it's got a different router ID, and it's also got an extra interface that I'm putting the link local address into. Apart from that, pretty much identical to what we did in router 1. And so, as you can see, there's no errors. And so from there, as you can see, we've also got a new adjacency now that there's two routers. So if we do show IPv6 route, we now will have some routes learnt from D. And so the ones with an A after cafe are my WAN links. The ones with cafe 1 is on router 1. And so there's cafe 2, which is the local one on the gigabit. This is the gigabit on router 1. And so as you can see, the next hop addresses are for that link local address that I put in there. So it all seems to be relatively happy. We can do show IPv6 protocols. And so it doesn't really tell you a great deal about who it's talking to, this one, but at least we have the interfaces correct. Suppose we can do show IPv6 neighbors. Oops, EIGRP neighbors. And that will, of course, tell us about router 1. All right, let's put router 3's config in as well for IPv6. Two new adjacencies. I don't see any errors, so it's looking good. Show IPv6 route. So again, we should have 6 networks. So there's 1, 2, 3, 4, 5, 6 networks. So all is good. Well, nearly all is good. Got a couple of little things to go. But if we do the show IPv6 neighbors now, oh, forgot EIGRP again, didn't I? we've got two neighbors, and so this is router 3, and so we've got router 1 and router 2 as neighbors. So that's all good information. All very happy. Now, so that's the routers exchanging information really well. Now, in the advanced chapter, one of the things it starts talking about is redistributing default routes. Now, of course, with RIP that you've done previously, when you wanted to advertise a default route through RIP, you did default information originate. And so that just says if I've got a default route, I will advertise that to all my neighbors. Sadly, and for a reason I'm not aware of, Cisco decided not to do that with the EIGRP. It's not an option. And so the only way you can actually redistribute a default route is redistribute static. Now, you could actually do redistribute static with RIP and also OSPF as well, but it's a bit of a blunter tool in that redistribute static will redistribute any static routes that you've got, not just default routes. While default information originate says if I've got a default route, I'll advertise it. This command says if you've got any static routes, and that could well be for individual networks as well as default routes, it will advertise them as well. And so it's a slightly, as I said, blunter tool. And so, of course, we've got to do that in both IPv4, so redistribute static in the router EIGRP1, and we also need to do it in IPv6 under EIGRP11, and so again redistribute static. So we only need to do it on router 2. So let's copy. Oh, actually, before I do that ping, before I do that, these are the on the ISP router. It's got that WAN link. It's also got a loopback interface, and these are the command. These are the addresses for it. So if I ping 10.10.10.10, that should work on this router. But if I do the same command on this router, it actually won't work because it doesn't have that default route. So it's failing. So yeah, no success there, 0%. So what I might do, I don't really want to type this IP address in again. Oops, didn't get all the address. Control C. So let's do ping, paste. So again, that's not working either. But if I do it on router 2, it should work. So I'll just copy that command. Is this router 2? Yes, it is. If I do this ping, it should work. And hey presto, it does. So router 2 has connectivity, it's just the others do not. And so if I have to copy this again, don't I? Copy, paste. And so we got those redistribute static commands in there. Let's have a look at router 1. We can do show IP route at the moment. And notice that it's probably going to have, yes, it's got that gateway of last resort line now. And it's also got this. And so D, of course, means dual or EIGRP. But it's got EX, meaning it's actually a route, it's advertising a route external to EIGRP. And so you'll notice that the admin distance is 170 as opposed to 90 for the internal routes. And so it deems that external routes are less reliable, but it's got a route. It doesn't have any other option. So let's do an up arrow. Let's try that ping, and that works now. Let's do the other ping. That works as well. So we've now fixed the topology, as it were, and so everything does seem to work now. And so that is a good thing. Now, about the only thing missing from this compared to what we had in the chapter is, I think in the chapter it talks about the percentage of bandwidth that the rating protocol is allowed to use. If my memory serves me correctly, it actually is not an option to be able to do that on Packet Tracer. So that command has not been implemented on the Packet Tracer simulator, so we can't really do that as such. But you can, I think by default it's 50% of the bandwidth, and of course you can either modify it up or down if you feel that need. So that's pretty much all I was going to demonstrate for today. Do you have any questions? Yeah, that was all right, was it? All right, so of course there's only 2 chapters on EIGRP, so 6 and 7 from memory, and so next chapters are actually, we start talking about OSPF. And so we talk about single area OSPF, which is basically not greatly different to what we've done here today, just a little bit different. And then we talk about multi-area OSPF, where that's where OSPF really comes into its own, is on very large networks. And then the last chapter, which I think will be the following week, we talk about tuning, much the same as the second chapter here was tuning for EIGRP. The last chapter for the course is tuning OSPF. So that's pretty much where we're going next time. I hope you're all well. I hope this was understandable for you, and I'll see you again next time. Have a good day, week, month. Stay healthy. Don't get the virus. All right, have a good one.